We have 86,000 and counting chemicals that are not regulated in safety for humans. In Europe, if you go to Europe, the chemical has to be proven safe before it's released in society. It's called the precautionary principle. In the United States, put it out there. If you suffer, you have to prove you're dying from it. That's the only way it stops. It's a little bit backwards, right? But that's an existing problem. It matters that you think positive. And I can tell you any one thing you do today other than eating well, if you start thinking positively, you will dramatically change your long-term outcome. So this is about food. So here are the USDA top 10 foods. Is any one single thing on that list really associated with good health? No. Colas, sodas. So you could beg the question that grass-fed beef is good for you. And there's some data on that, but most American beef is bad for you, right? No good, terrible, 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 not good, questionable depending on who you are. So 2 out of the 10 things may be associated with some health. The rest of the 8 are really bad for you. And of interest, which one turns to sugar faster in your bloodstream? So what we call glucose spike. This one or this one? Anyone know? The bread. Bread is actually the #1 bad food on the planet for humans because it turns to sugar like this, which spikes your insulin like that, which then inflames your body, right? Let's talk about some differences in colors, right? You go to the United States, we use dyes to color our foods. You go to Europe, they use natural things. Why? Cost. So the experiment I did 2 years ago, last week, I bought McDonald's and Burger King and just put it out on my desk and just opened it and left it there. What do you think happened to it? Oh, it's hard. It did for a week. It no longer smells. There's not a single odor coming from it anymore. But that's what it looks like now. Everything's desiccated, not a single ounce of bacteria or growth or anything on it, no mold, nothing. And McDonald's is selling billions of these things, right? Why is that able to preserve itself? All right, you guys got it. All right, so I'm going to read this. This is probably the only thing I'm going to read. Rather than chemical conversion of food to energy and body matter of classic metabolism, food is now also a conditioning environment that shapes the activity of the genome and the physiology of the body. It is thought that food in prenatal and early postnatal life impacts adult-onset diseases such as diabetes and heart disease. Exposure to food is seen as that point of potential intervention in long-term health of individuals and populations. What does that mean? We are now at the point of understanding truly that food is probably the #1 reason we're dying. Very few other things have the impact on our life expectancy and our disease rate than food. And this, essentially, unfortunately, this is the biggest problem. Before children are born and after they're born immediately is where most of the damage is occurring. So let's talk about some mismatch issues, because this is going to lead into a topic I really want you guys to understand called epigenetics. So if you're a polar bear living in the desert, what's going to happen? So let's talk about mismatches that are occurring now. If you have light skin and you reside in Miami, you have huge risk of skin cancer, right? Because you burn. You're Irish. You're supposed to live on an island up in the middle of the North Atlantic, and instead you move down to Miami, which is about the latitude of North Africa, and you burn. So you end up with cancer. Makes complete sense. You have a mismatch now of your genetics, where you're supposed to be and where you're found. Let's say you go the other way. Let's say you have darker skin. Your heritage is from middle of Africa, and you move to Boston. Now what's your big risk? Vitamin D deficiency. The skin is darker because historically you lived in an area where the sun needed to reflect back because the sun is very hot. Congo, right? So your skin is exceedingly dark. Take that, move that person to Boston, where the sun is not nearly as intense. They reflect back so much of that sun, they're vitamin D deficient. #1 risk factor for autoimmune disease and cancer. So you start to see these patterns happening. Pima Indians used to live on the land, ate grass, foods, anything that came from the land, and they did very well. Now we've switched them, put them on reservations, and gave them flour, sugar, and fat. They have the highest disease rates in the world of diabetes, metabolic syndrome, hypertension. It's a mismatch, okay? And then last on this list, baby born in famine times lives now in a caloric-rich world. They have metabolic syndrome. It's very clear that what happens to you in your life epigenetically is based on what your experiences are. So we have a problem. Canary in a coal mine. They used to put canaries in coal mines because if a canary died, you knew to get out of the coal mine because methane gas had been released and you're all going to die, right? The canary in the coal mine now is the American population. We are the poster child in the world of what not to do to stay healthy. We are exporting our badness. You go to China now, you go to Kuwait after the Gulf War. Kuwait has some of the highest rates of obesity in the world now, and they almost had no obesity. But when the GIs travel around the world, they generally take McDonald's and Burger King and these other companies with them, and then they leave them. McDonald's in Beijing has a 24-hour service, and the line is around the building all day long because they think American things are great. So let's understand quickly genetics. We're going to fly through this part. So Mendelian genetics, this is sort of a joke, but this is the kid, it comes from, the dinosaur and then comes down and the guy got left with a tail still. But genetics, Gregor Mendel was the first guy to figure out that if you put mom and dad together, the baby's going to come out with half dad's genes, half mom's genes, right? So who's that guy? What? Charles Darwin. Yeah, speak up, guys. Who's that? Yeah, it looks like him. Nope, that's Jean-Francois Lamarck. So what did this guy say? So he said, what happens in evolution? How do you evolve? Survival of the fittest. So if you're no good, you die out, and the guys who survive then procreate, so their gene pool carries on. Lamarck at the exact same time said, nah, I don't think that's entirely true. I think we evolve and adapt as the years go on before we die, right? He was laughed out. As we know, Darwin won. Darwin's always been the poster child now of genetic evolution, and Lamarck was so wrong. Lamarck is absolutely right. Lamarck has been well proven that a neck of a giraffe will stretch in its lifetime if the canopy goes higher, right? So they're both right, and so we're going to talk about why that matters. So the theory of epigenetics, right? When I was in medical school, we were told that your DNA is your DNA, right? You've got a book of life in every cell in your body, and that's who you were. Half dad, half mom. Sorry, if dad had heart disease, you're going to get heart disease, you're going to die. Not true. And we know this now because the epigenome says that on your DNA, you can have sticky notes put on that say, don't read me, and then you can end up with certain genes being read. And what does that is the environment. Anything can turn on or off genes. Food, chemicals, air, bad air, experiences, anything that changes how your body it sees the environment can change how the DNA then functions and what you become, what we call the phenotype, or who you look like. It's an analogy that you guys will understand if you understand computers. So you think about your DNA, that's your genetic code. That's your hard drive. What does a computer do if you don't put software into it? Nothing. It's absolutely useless, right? Let's say you put the software into it. That's your epigenome. So any software input to your computer makes it functional. Anything you put in your bodies, any experience you have, has an effect on your DNA. And I hope you guys drill that into your head, because if you start to understand that, you guys really understand how to be a peak performer. So when the Human Genome Project started, they assumed that the human gene pool would be huge, right? Look what happened. When they finished it, the human genome has 24,000 genes. The worm genome, 21,000. How is it possible that that little tiny worm in the earth has 3,000 less genes than we do? And then the fly, we have less than double. How is that possible? How can we be so complex with only 24,000 genes? It's the epigenome, right? All those signals that can tell the DNA what to do and what not to do is how we become so complex and how we're so functional. Seminal case, this gentleman came and lectured here once about 5 years ago, Randy Girdle. So he was the first person to prove the epigenetic theory. So he took a mouse called the agouti mouse, and the agouti mouse by nature is going to have a yellow coat, be fat and diabetic. If you do nothing to mom and dad, you put them together, they're always going to make a fat, yellow, diabetic mouse. Then he said, okay, well, let's do an experiment. So they gave these mice, while they're pregnant, methylators. You guys ever heard of methylation? That's a carbon atom with 3 hydrogens attached to a different chemical. That's called a methyl group. Well, this is found primarily in vegetables, fruits, and all these things. Great stuff. So they gave the mom, while she was pregnant, the methyl donors, and what came out is a brown, skinny, and non-diabetic mouse. So now we, for the first time, proved that when you put a methyl group on the DNA, you can change how the DNA gets read. Now we have proof of concept that what you do affects how your DNA is read and affects who you become. So then the same lab went back and said, okay, what happens if we keep giving methylators to the pregnant mama and we also give chemicals? A big chemical known as BPA, bisphenol A, right? You ever heard of that? It's a plasticizer in hard plastics. You know, Europe has banned it. America says, oh, it's fine, no problem, right? This was in baby bottles for years up until about 6 years ago. So they gave these mice the same thing, and what happened? The babies came out fat, yellow, and diabetic again. So what do you have now? You have a push-pull between good and bad. If you give the right things through food, you develop right genes. If you counteract that with chemicals and bad stuff, you can flip-flop the problem. So when you think about peak performance, and you think about what you do on a daily basis, if you eat a meal for lunch before a lecture that's loaded with flour, how can you peak perform? Because you're going to be sitting there digesting and getting exhausted, so you're going to maintain less information in your brain afterwards. This is how you prove that that's the case. So here's an example of some idiotic things we do with chemicals, right? So here's this guy up in the Andes smoking 1 million cigarettes at a time. Huge epigenetic nightmare. Valproic acid is a chemical we use. It's a drug we use for seizures in kids. Well, now we know, when I was in medical school, it's called drug-induced lupus. Lupus is a really bad autoimmune disease that messes with your body everywhere. Rashes, brain disorders, you name it. Affects your heart. Well, it turns out now that this valproic acid takes those methyl groups off the DNA and then allows a certain protein segment to be read that turns on lupus. So there's another example of an epigenetic scenario. Dosage and timing are key. The critical times of understanding what it is to be healthy is pre-birth, birth, and then teenagers. You guys are the highest risk for doing good and bad to your body because you're growing like that. Your cells are rapidly turning over. You're increasing in size. That's when you need to be taking the most care of yourself. But yet nobody talks about it. You don't hear people going into schools and teaching teenagers that this is so important for y'all. It's more about, you know, what not to do on a cell phone or what, you know, I don't know what other classes you have, but very few of them are teaching you guys really what it matters when it comes to food. So here's a picture of the United States in 1986. That blue segment there is a 10 to 14% obesity rate. Now that means defined as a body mass index greater than 30, right? So if you have a body mass index greater than 30, you are technically considered overweight, right? And well, who cares if you're overweight? If it didn't mean you had disease, nobody would care. It wouldn't be an issue at all. The reason it matters tremendously is because that is the marker of disease. People who are overweight, unfortunately, have much more risk of developing bad outcomes from many different things. I know this is uncomfortable for some, but this is really important. So look what happened in 4 years. Category is still the same, but the volume's picking up. So there's a 6 year, let me go back. There's a 6 year jump. We have a whole new category, up to almost 20%. All right, so this is 14 years. Half the country now went to 20 to, that's Colorado. Colorado, it's the what? Oh, they're smoking too much? No, Colorado. Yeah, Colorado actually has the highest rate of exercise in the country. They do. They have the highest rate of exercise in the country, and they do actually eat predominantly a bit better than the rest of the country.